Hello everyone, welcome to SciSoft Academy. Here we are empowering the education through digital content. So this is me Mallikarjuna and today we are going to see the basics of radar tracking system. So without further delay, let's get started. So these are all our today's session outlines where we are going to see what are all the basic parameters involved in radar tracking and what is a block diagram of it and what are the basic methods of tracking system, and we'll see a short description of each one of them. So I hope this is clear for you. So let's start with the parameters of radar tracking. So these parameters which we are going to talk about, so all these parameters have been discussed in the previous videos itself. So I'm just going to revise it once. So let's talk about the first one. So we already know range. So this parameter is actually defines the distance between the antenna and the actual target object. And we have already seen about the azimuth angle and elevation angle, and these are all our second parameters. And when we go to the third one, it is the frequency drift. So frequency drift is nothing but the velocity of the object. So we are going to identify different parameters such as range, azimuth and elevation angle, and frequency drift or velocity. So these are the basic parameters of radar tracking. Now we will move ahead with the block diagram of it, how a radar tracking system works in live. So as you can see, this is a very basic block diagram of a radar tracking system where we'll be getting the target data from the antenna to radar system, and then the radar system identifies various parameters such as elevation angle, azimuth angle, the velocity and the range of the object and etc. So these informations are going to be calibrated and the error is going to be calculated out of this data, and based on the error the command is going to be sent to the servo motor. So this servo motor actually helps us to adjust the direction of the antenna so that we can minimize the angle error and elevation angle error or azimuth angle error. So based on this feedback given, the antenna is going to be adjusted. So this actually works as a feedback system which helps us to minimize the error and maximize the accuracy of our system. So I hope this is clear for you. So now we'll move ahead with the basic tracking methods involved. So as we can already see in the outline session, so we have three basic tracking methods. So first one is sequential lobbing, and second one is conical scanning, and we have a monopulse method. So let's see a short description of each one of them. So I'm going to start with the sequential lobbing. So in sequential lobbing, basically we'll be having two beams, which is going to help us to identify the target by keeping the target axis in the middle of the beams. So of course, so there are some problems with the sequential lobbing, and there are some applications also with the sequential lobbing where we can use this. So let's go ahead with the problems of using sequential lobbing. So when the angle of the beam is more than the angle of the error, so we are actually losing the accuracy of the tracking system. And if suppose if you are using a pencil beam, then the tracking region decreases. So and one main thing about the sequential lobbing, or we can say disadvantage. So by using sequential lobbing, we can actually identify the direction, but not the position actually. But of course, it has some applications such as so this sequential lobbing can be used in ground-based radar tracking systems. And I think I've covered most of the sequential lobbing things. So now let's go ahead with the conical scanning. So when we talk about conical scanning, so basically here we'll be having only one beam which is going to rotate continuously. So based on the rotation of the beam, the tracking of axis is going to be formed, and the target object is going to be detected based on the rotation of the axis, based on the rotation of the beams actually. Sorry about that. So I hope this is clear for you about conical scanning. So now we will move ahead with the monopulse method. So in monopulse method also, we'll be having similar kind of structure where here also we'll be having a rotational based tracking system, but here instead of a single beam, we'll be having the single beam split into two beams. So each of them is going to be polarized opposite to each other, so that based on this, the tracking accuracy is going to be increased. So this is one of the important application of monopulse method. So yeah, I hope this is clear for you. So do let us know if you have any questions in the comment section, and we have captured all the outlines and notes in the cloud, and we have shared the link in the description. So thank you for watching this video, guys. See you in the next one.